So I hope you have understood about the electrophoresis and also about the precipitation also. How does precipitation occurs on the colloidal solution. So in this section, in this video, we are going to study more about this flocculation or the precipitation. So we'll be studying in depth about the how does precipitation occurs and what are the factors which influences the precipitation, and also about how can a lyophobic soil attain stability. So thereby we will finish our properties of colloids. That topic we will finish by today. I hope you have understood the properties of the colloids. So many questions are expected. We can expect lot of questions from this part for our board examination. So if you have any doubts, please clear it before moving to the next topic.
So we were discussing about the addition of an electrolyte. How does the addition of an electrolyte causes the coagulation or precipitation of a colloid? So if we add slight amount of electrolyte into the colloidal solution, the ions present in the electrolyte will neutralize the charge on the colloidal particle. Hence the colloidal particle will lose its charge and it will come together and will settle down under the gravity. So it will undergo the precipitation. The ion which is responsible for this neutralization, we call it as the coagulating ion. The coagulating power of the coagulating ion can be explained by using a rule known as Hardy-Schultz rule. It states that greater the valency of the coagulating ion, greater will be its power to coagulate. That means valency of the flocculating ion and the coagulating power are directly proportional. So let us look at an example of the different cations which can coagulate the negatively charged colloidal particle. The ion with the more positive charge has the more capacity to coagulate. That means tripositive ion has more power to coagulate, then comes dipositive, then comes the monopositive ion. Let us now look at the anions. The power of the anions to coagulate positively charged colloidal solution. Ion with the more negative charge has the more capacity to coagulate the colloidal solution. That means the ion with the 4 minus charge, it has more capacity, then comes -3, then comes -2, and the last is with the -1 charge. Coagulation won't take place until the amount of electrolyte that we are adding reaches a particular concentration. So that minimum concentration of the electrolyte that is needed per liter to cause a salt to precipitate in 2 hours, we call it as its coagulating value or flocculation value. It is important to note that lesser the coagulation value, or that means lesser the quantity needed, greater will be the coagulating power. Let us now look at the example. The cation with more positive charge and the anion with more negative charge has the coagulation value very less. It has a very less coagulation value compared to the other ions. That means lesser the coagulation value, greater its coagulating capacity. Now look at the stability of the lyophilic salts and lyophobic salts. Lyophilic salts are more stable than the lyophobic salt. Lyophilic salts won't get coagulated easily. What is the reason for that? The first reason is that existence of the same charge on all the colloidal particle. The second reason is that extensive solvation of the colloidal particles of a lyophilic salt. So these two are the two reasons for the more stability of the lyophilic salt. Now we know that lyophilic salts are stable, but adding excess amount of electrolyte or the suitable solvent can cause the coagulation of the lyophilic salt. But lyophilic salt requires higher amount of electrolyte, but lyophobic requires only lower concentration. So for a lyophilic salt, suppose it's a solvent is a water, if you are adding suitable solvents, it can cause the dehydration of the water molecules. When the dehydration takes place, it will get coagulated, it will settle down under gravity and it will get coagulated. How can we protect such colloids? How can we protect the colloids from coagulation? Lyophobic salts like metal salts are very subjected for the coagulation or precipitation. So, process of protecting them from the coagulation we call it as the protection of colloids. So, how can we protect lyophobic salts from coagulation? So one method is by mixing the lyophobic salt with the lyophilic salt. It can cause the coagulation very less. Even if we add slight amount of the electrolyte, it won't get coagulated easily. Why is it so? Because lyophobic particles are these lyophilic particles will protect them. It will accumulate on the surface of the lyophobic particles and will protect them from coagulation. It will prevent the particles of the lyophobic colloids from aggregating if the low electrolyte is added. For example, if you are adding gelatin, which is a lyophilic salt, to a lyophobic salt, gold salt is a lyophobic one. So, if you are adding this gelatin will protect the gold salt from coagulation, even if a slight amount of NaCl. NaCl is an electrolyte. Even if it is added, gelatin will protect the gold salt. I hope you have understood the Hardy-Schultz rule and how does a colloid attain stability. Thank you.